Hello, my name is Alexander, and welcome to my 15-112 term project. My project is called somseD. It's like Desmos, but backwards. Essentially, the main premise is that you can draw on a graph and get a function in return instead of you typing a function and getting a graph back. That's why it's like Desmos, but backwards. However, you still can graph functions. For example, you can graph a linear function, like say 1/2 x, so 0.5 plus 1. And you can also graph other function families. Let's say you can do a natural log of a polynomial, and you type in the coefficients like 3, 0.5, and 2. And it will graph that for you. You can also do different polynomials, say 2, -10, 12 for a quadratic, or you could do a fourth degree. For example, you could do, let's do -0.1, 0.5, -0.424. I'm just pulling out some numbers, and there you go. It'll graph that for you as well. Now, the more exciting part of my project, or the one that I think is quite a bit more complicated, is the fact that you can draw on this canvas and get back a function. So if you draw a line, it turns out that oftentimes a third degree polynomial fits the best, but you can also graph multiple curves on the same canvas. So if I draw that, and let's say I draw this, I can graph all of them at once, and I can cycle through them and show you the functions of these equations or of these graphs, and I'll show you what the best fits are. And as you can see, if the best fit is a third degree polynomial, it will tend to do that one. But for more complicated or wider curves, it will go to fourth degree polynomials. And if you have just 2 points, it'll do a line. Because it tends to be that the line is the most accurate regression or best fit 2 points. And you can also get fifth degree. It's a little bit harder to force because it does this automatically. That's a fourth degree. Say I do something like this, it returns a fifth degree polynomial that has the best fit to this set of data. And my favorite part is the point plotting mode, because you can start with 2 points and then press R to make a best fit or regression, so to speak, of the scatter plot. And as you add more points, it will make a best fit of the data you have. You can also do it with more points. Let's say I do something like this. It will make a fifth degree polynomial. You can also do a curve. We'll take all of the points and return the best fit. That one was similar to a third degree. But if you do like a parabola almost, it should return, well, in this case, a fifth degree. But if I can draw a really nice even curve, then it is a fourth degree. Now, the way I do this is I have an algorithm here that will calculate all of the different errors. So this is my standard error function here. And when I'm actually finding the regression, I calculate the standard error for each and compare them. But if the coefficients for a certain function are very small, say smaller than 0.005, I will return the next lowest. So instead of a fifth, I would return a fourth degree polynomial. And then I also have the different regression functions here. These are the polynomials. This is the quadratic. Turns out usually fourth degree polynomials are more accurate than just quadratics. And here's a linear one. And there are also ways that it will end up partitioning the points so that it can draw multiple at once. Ended up passing that actually, but it does it here. It will draw just the individual lines itself here. And that's how you're able to have individual curves and then cycle through them. Oh yeah, right here. So it can draw them all at once when it's true or when it's false. We'll go ahead and cycle through them as you press the arrow keys.